Alright, so I've got the same setup as in Gostling. So we got the two balls, 1-3 mass ratio. They are almost quite perfect. I've added a little, like a coin at the bottom, to make sure it's almost a perfect 1-3 mass ratio. So now this is not one big circle. This is 1/4 of a circle for the small ball and 1/4 of the circle for the big ball. So this is like the radius for the small ball, and this is the radius for the heavy ball. Okay, and so this is the quarter circle for this ball, and this is the quarter circle for this ball. And then we have the heights. This is 3 centimeters high, so let me show you. Three centimeters, and then 4 times higher. Yeah, hold on. Which is 12 centimeters. You can see that, right? 12 centimeters. Right? And the same on this side. This is 3 centimeters. That's all we need. This is the half velocity mark. And the 1.5 centimeters is the quarter velocity mark. 1/2. 1/2. So now I'm going to pull this one up towards here, towards the film mass, and then we will see whether or not they will bounce back to here or to here. So you can see that this ball nicely follows this red line. All right, I'm stretching the pendulum. All right, so just to show you that this circle, that this quarter of a circle is almost perfect. The same for the heavy ball. All right, so it's aligned with the center of mass roughly. I'm stretching the pendulum. It nicely follows the line, the curve of the line. All right, so the quarter of the circle is not a flaw. All right. Let's check out the masses of the balls. 32.40, so times 3 should be around 97. And we have 96.95, so almost a perfect 1-3 mass ratio. So I have done a couple of recordings with my slow motion camera. Now I will do a recording with my phone, which is a better quality camera. Here we go. All right, and that's it. I already know what you're going to say. You're going to say that the balls bounce back a little bit further than a 3 centimeter mark. You know, instead of this side of the ball over here, it went over here, and therefore something must be wrong. But no, that's because when I let it drop, it's kind of difficult, all right, to position the very left side of the ball with the line because I'm like dropping it from above. That's my vision. That's my view. And so on average, I let it drop from this position. So roughly at the center of mass almost, or a little bit more than the left side. So like over here. So ideally, when it bounces back towards here instead of here, instead of this, but like this should be correct. All right? Of course not all right. It's a flaw. So go ahead and tell me again that I'm engineering this experiment. How the hell am I supposed to engineer this experiment? How am I going to fake this? All right? This is real rope, just rope that I use as a pendulum. These are real marbles. I've shown you the weights. I've drawn the circle. I've measured the heights. And all I'm doing is this. I'm letting it drop from this height. And then everything else is nature. There's nothing else behind these balls. No special motors, no magnets or anything at all. Nothing. Tell me, how the fuck am I supposed to fake or engineer this experiment? Huh?